I have a 65 ampere hour sealed lead acid battery which I charge with my 180 watt monocrystalline PERC solar panel using a pulse width modulation charge controller. As part of making the whole radio room run on solar energy, I have a 1150 watt inverter which can run my pedestal fan and LED tube lights on 230 volts AC. Then I thought that if I can bypass the inverter by using 12 volt LED tube light, that might save some energy loss due to conversion. I had posted about the internal structure of a 20 watt 230 volt AC LED tube light earlier. The LED strip inside the tube light contains a total of 87 LEDs. There is a driver unit along with it. If one LED needs 3 volts, the 87 LEDs in series would need 261 volts DC output from the driver circuit. Just to check it out, I connected mains power to the AC input of the LED driver unit. The input AC voltage was around 216 volts. Output of the driver unit was seen to be around 120 volts. That would mean only about 1.38 volts per LED if all the LEDs were connected in series. That was rather odd, as most white LEDs need 3 volts for illumination. There could be some error of measurement in my old digital multimeter, or the output may not be a true DC. Still, the AC input measured by the same digital multimeter seems to be in the reasonable limit for a 230 volt rated main supply in this region. Inset on the right side with the blue border shows 3 copper strips between each LEDs after scraping off the insulation with the sharp edge of a small pair of scissors. The broader central strip connects the LEDs in series, while the narrower strips on either side are the positive and negative supply lines coming from the driver unit. In the pink bordered inset on the left side, middle of the central strip can be seen as cut with a sharp screwdriver to disconnect the connections between every 4th and 5th LEDs in the series. Video clip shows checking of continuity between two sides of the cut central strip. Aim is to have no continuity between the two sides of the strip. It takes a little bit of meticulous work with the screwdriver tip to cut the strip without damaging the positive and negative lines on either side. Occasionally they do get damaged when the screwdriver slips. Now the LEDs are in groups of 4, so that 3 into 4 is equal to 12 will be the voltage needed for them to glow when connected to the battery. I am trying to test a segment of an LED tube light, and you can see that it is quite bright in spite of the fact that I have put a piece of green colored heat shrink over it. Here I am showing the copper strips which are exposed by scraping the LED strip. You can see that there are 3 of them. I have connected the negative to the central one and positive to the positive terminal on one end of the LED strip. Now comes the tedious job of connecting 21 sets of 4 LEDs each together to 12 volt battery. Not sure whether the thin positive and negative strips will take the higher current at lower voltage for long duration without heating up. That would be 20 watts divided by 12 volts is equal to 1.67 amperes. While working at higher voltage like the 261 volts DC which I had calculated initially, the current need be only 20 watt divided by 261 volts is equal to 0.077 amperes.